right? I have to ask the absentees, but the thing is, they're not there. How do you ask them when they're not there? These are some other. Okay. Yeah. Sure. Yeah. Sure. Sure. Thank you, Professor Datta, and again, good evening to the few people who are here. Hopefully, we will get more participants coming in as we go ahead with the session. So, let me start with a simple concept in the systems theory, and we relate it to a project and to other things. So, yesterday we saw that a system is something that has a set of constituents, components, which interact with each other and which produces a definite output or a result. And I also mentioned in passing yesterday that a very important concept in a system is that of a life cycle. Any project you take, any system you take, any product you take has a life cycle, right? In a living organism, and somebody very correctly said, life cycle has actually two words to it, a life and a cycle. And I've given this slide here to show what is the concept of a life cycle of a living organism. So in biology, you know that every organism that has a life starts with a birth, then it grows, it matures, it declines, and finally there's a death. And of course, I put a dotted arrow to say that not for any religious purposes, but in Hindu philosophy, we believe that there's a rebirth. So after the death of one organism, another organism of the same kind or different kind will take birth again and again go through the same process round and round. This has a lot of meaning for projects and systems and hardware and various research topics that we'll be talking about. And I'll come to that in a minute. So, if you take a project, for example, I think I've got a slide here which will talk about the, not here yet. Okay, I'll come to that in a little while. So, project has a conception. Your research problem, for instance, has a conception. Somebody has thought about it. Maybe your guide or you yourself have thought that I need to work on a research problem. So the idea takes concept in your mind, in your brain. For instance, I did various research projects. I'll give two or three of those as examples. At my bachelor's level, I did a research project on design and development of a rotary power weeder for soft wheel conditions. So this was a mechanical device, part of an agricultural implement, to remove weeds from the paddy field. I'm sure Professor Bola Nath knows it very well, and others who grow paddy in either Bengal or Bangladesh or in southern India. That there are two ways of cultivating paddy, and most often paddy is cultivated in lowland conditions where you have a kind of a pan, this the foundation or this layer below the water is normally clay or impervious layer. So water, there's standing water in the field, and because of this, you have a lot of weeds that grow in the field. And a machine that we developed and designed at IIT Kharagpur, which also won the ISA Silver Medal Award at a convention, that machine basically removes the weeds from the paddy crop, from the field. So that idea came because the birth of that project or that idea occurred because I had observed, during my field visits to various farms in West Bengal, Midnapur district, that there are lots of weeds that grow in the farms. So that's where the birth of the project took place. And then as we thought about the project, it grew in size, it grew in concept, grew in scope, and we started analyzing how we are going to put this machine together. So in terms of gathering resources in a project, or in terms of defining the limits of, I'll come to the project definition, system definition in a minute. So in terms of defining these boundaries, the project concept, which was at birth a very vague concept. It started growing, and then it reached a maturity stage when we were sure that this is the kind of a model we want for this particular project. So we worked on this for quite some time, and then finally we got to the stage where we knew that this was a particular project we want to implement. That is the maturity state of the project. And then once we got the maturity stage, we built the machine, we took it to the field, we demonstrated it to the farmers that you run this. It's a very simple handheld rotary weeder. You run it in between the rows of the paddy plants, and it removes the weeds, and it gets does the job it's supposed to do. This helped in reaching the maturity state of the project and defining everything we needed. But after some time, we noticed that there was a decline in the interest in the project. Maybe better machines came, better devices came, and there was a decline in all systems. When you have a birth, you have a growth, you have a maturity, you decline. And after some time, we found that this particular idea had a natural death in the sense no longer being used. Instead of handheld devices, people had devices with wheels, so that you don't have to lift a weight. You can design it such way that the wheels are in the rows between the plants, and you move the machine either on a two-wheeler or three-wheeler or four-wheeler, and use different devices. You can use a power tiller, for instance, as a weeder. You can use a mini tractor as a propelling machine, and so on. So a new idea comes up, grows, matures, declines, and dies. This concept is very useful when you think of your research project, because that research project will be having a lifespan which is from the birth to death of the project, and beyond that, it's going to be uh, transmuted or transformed into a different project. And let me stop for a couple of minutes, and if there are any comments, discussion on this, I'll be happy to take that, and then we continue to the next slide. I don't know how many people are there. Let me just go to the scene here. We are just still four of us. So Professor Datta and Sanjay Bharti and myself, and Professor Mishra, of course. Comments, gentlemen? Any suggestions?
No, it's
Sir, when we
fine, sir.
design,
It is well explained. Thank you, sir.
Thank you. Sanjay Bharti, you are about to say something?
sir, it's a very much you interested from your side, whatever we are getting. First, we perceive the things to design and develop the machines, which can give the result for betterment of the society, as well as if you look for the research work, it's give
Hmm.
us the in-depth knowledge. What are the
Yeah.
problems we have, or what
Hmm.
problem can be occurred from the environment
Yeah.
or
Yeah. Good. So I think research methodology we can use to have a systems approach or to have a holistic view of the research problem that we are going to be looking at. Wait a minute, let me get back to this. Another concept you can look at for a lot of the engineering systems and even in the research area is how do we go from an idea or a concept. Let's say you want to develop a new product like the rotary power weeder. How do you go from the idea or the concept? How do you go from that idea to a final product or process or service? This is done in a lot of the research work that happens in areas like product design and manufacturing, new product development. In fact, I was involved with a lot of you know all these all our research projects and all the product development exercises. We start with the idea or the basic concept, and we move from that to the basic research, which is to delve into depth on that idea. So, for especially the research students who are taking this course on the research development program, You have an idea, you know why you want to do a research in a certain area. The basic research would be essentially to do the review literature to find out more about the topic that you've selected. And then you'll do applied research in terms of working around that topic and to see whether you can develop some conceptual models on that. And then you design development means different things. In the case of the Tata Nano car that I mentioned as an example, a design development of the car is what we will be doing. But in the case of the empirical research work, design development of the research would imply you're putting together a questionnaire, you're forming the instrument for data collection, and so on. From there, we go into the actual production of the vehicle for a Tata Nano, or we go into the actual process of the data collection, engineering part. You go around, go do surveys, collect the data, okay, and then we do the analysis, which is equivalent of the manufacturing. Manufacturing, in a research sense, means we are not manufacturing, but we are trying to generate the data, the results and conclusions from this project. We do that. In the car, of course, it means the actual physical manufacture of the car. I'm just giving examples from across different sectors. And then finally, in a physical product, we do the marketing, take it to the market, let the customer know what this is about. In the case of a research project, marketing here really means writing up your research results, putting it in the form of a thesis, and publishing it or communicating it to the outside world. Because even otherwise, the process, the main job of any marketing exercise is a communication, whether it's a communication of the physical product like a Tata Nano or it's communication of the results of a research work is what a research scholar would do. And end of it, we end up with a product or process or service, which is what the society sees at the end of the whole exercise. So in the case of the Tata car, for instance, they will see the physical product, the car which is on the road. And I was mentioning earlier, during the initial phase of this development and deployment of the car, maybe every 2 and 5 cars on Indian roads, especially in cities like Pune, Bangalore, and Hyderabad and Chennai, were basically nano cars. But today, that car has virtually been extinct in the market. It's no longer there. So we see very few of those cars in our cities today. Okay. Any questions, comments on these few slides? Actually, I was explaining them when I realized that I was offline and I was basically talking to myself in that earlier part. Open for questions, open for comments. Professor Mishra, Professor Datta, and there's a new gentleman who joined, Gino, lady, I'm sorry, Angeline Gino. You want to say something, madam? Anybody? I'm throwing the floor open for discussion now. No, no comments. Hey, are you there, Professor Datta? Can you hear me? Okay, because silence is something very puzzling to a teacher, right? When you're teaching a class and nobody is.
We are imagining your these pictures and how do it work and how can we use it.
Yes, exactly. Yeah. Okay. Anybody else? I think, let me see the name of all the people who are here. Uh, yeah, we have Professor Datta, of course, the president of Knowledge Cafe, Professor Mishra, Sanjay Bharti, Evangeline Ginu. Can you introduce yourself, madam, just to make sure that I know you're there? We go to another related concept in the system design process, and then we'll come back to looking at the various stages of the research work itself and how the system concepts applies to these. Right? So yesterday we were talking about how we define a system and how we design it, how we analyze it, how we control it. And the system design part basically is to look at a need or a problem and come out with a product or a solution, a process or a service. Okay. So this, I have this. I'm unfortunately not able to share it, but I have this algorithm which I call as the system design algorithm. We start with something called a primitive need, which is a need, expressed in a very very rudimentary form. So when I worked on one of these problems for a rice mill in Midnapur district of West Bengal, the primitive need that the farmers had was that they just said that we need to convert the paddy into rice. You cannot eat paddy because of the husk and the shell and the uh, the hard part of the paddy on the outside. We need to uh, hull it. We need to remove the coating, remove the husk, and then you can the rest of it is the rice. You can use that. Start from the primitive need, and then we do a feasibility study. Okay, is it possible to do this from a technological point of view, from a financial point of view, from a economical point of view, from a social point of view, from a political point of view? Obviously, the answer to all this for the paddy exercise is yes. Then we look at possible solutions. We can do this process mechanically, by hand, by a semi operated machine, or a fully automatic modern rice plant. Then we do the preliminary design, and so on. So each step by step will take us from very rudimentary needs to the final product or process or service and how that design gets used. Okay. This is the various steps in the system design algorithm. And one particular step that we use in this very often is what I call the uh, feasibility study part of it. And in this study, what we do is we start with a primitive need, again, to convert paddy into rice, let's say. But from that, we grow into a read which says, I'm sorry, I think you're able to see me now. I think the camera pointing was a different direction. You can see me now. Otherwise, you're seeing my room furniture, which is not what I intended to show you, gentlemen. So when you start from a primitive need, we do the needs analysis, right? So in any research project, you need to ask a question: who is the customer? Who wants to use this research project, or who wants to use solar device, or who wants to use a, paddy processing machine or a modern rice plant, or who has a need to convert the paddy into rice. So these questions we need to ask. And while knowing those answers to the questions, we can identify more specific needs. Okay. So instead of saying that I need to convert paddy to rice, I'll now start saying that I need to design a semi-mechanical or mechanical system for converting, let's say, 10 tons of paddy per month into edible form of rice, for serving, let's say, a population of a few lakh in an area, and with inputs, financial inputs of up to 1 or 2 crores that I can invest in the plant, and subject to an operating cost of maybe 10 to 20,000 rupees per month. So we start putting more parameters into our needs analysis, and we get the identified needs for the system. Then we do a system identification. So we now start asking questions like, what are the inputs to the system? What are the outputs? What we did yesterday, what needs to come out. Then we also ask questions like, or some people call it the activity analysis. We do analysis of various things that go into the system. The so-called, we looked at the black box yesterday, the system design box, and said the various functional properties of the system we need to analyze, and all that will be defined in the identification of the system. And finally, now we are ready with a detailed problem statement which will say, instead of just saying that I need to convert paddy into rice, I will now say that I need a semi-mechanical or a fully mechanical system that can process 10,000 tons of paddy per month and give me these qualities of rice for serving people of this community or this area at a price point of maybe 50, 60 kilos rupees per kilo for rice, and so on and so forth. So I can identify all the engineering technical parameters in the problem and put out a detailed problem statement. And then and only then should we start synthesizing solutions. So to go back again to the example of a research work, when a research scholar identifies the primitive need, why she is doing a research. She does an analysis of those needs. She finds more specific needs. Maybe the research is required as a part of a master plan or something like that. But research could also be required as part of a professional organization. You could be, let's say, a part of a United Nations organization and you're doing some study. Research could also be required as part of a corporate setup. Let's say you're with Goldman Sachs, and Goldman Sachs wants to do country profile research or they want to do industry sector research. So then you will tailor your research according to the identified needs in that area. You do the analysis of the system to find out in a research example case, you would like to analyze what kind of models do I have with me, what kind of data can I collect, what kind of software I have for analysis of the data, and so on and so forth. You put a lot of these things together. After you've done all that, now you have complete detailed problem statement, which is to say that within a period of 3 months or 6 months or 3 years, I need to solve this problem. I need to find a solution. I need to be able to write up the report. I need to write up my PhD thesis and submit that as a final output of my research work. All this will be a part of the detailed problem statement, and then only then will you start synthesizing solutions. So the solutions for the paddy processing plant example would be a purely manual kind of you know paddy husk removal, which will be simple manual hullers, or you could have semi-automatic plants or fully automated modern rice plants. All these are possible solutions. From the possible solutions, you will finally find out which are the feasible ones, right? Even for the research project, for instance, possible solutions could be doing the research in a case study method, doing the research in a totally modeling simulation, mathematical method, or doing the research in a semi mathematical but empirical method. All these are possible ways of solving the research problem. You look at these and then find out which is feasible. How much time do they have? How much money do I have? What kind of software tools do I have with me? What kind of data collection facilities do I have with me? Looking at all this, then you'll select a particular set of feasible strategies or feasible solutions or feasible products, which you would then take forward to implement your research project. Okay, this is I'd say one of the most important slides, what I call a feasibility study algorithm, which you'll have to use for every project, for every manufacturing exercise, for every production system, and also for every research project that you're going to undertake. I'll leave the floor now for a few comments or questions, and I will now get back to the next set of slides which I have, which will talk about the entire research process itself. Okay? So, Professor Datta, Professor Mishra, Mr. Uh, Bharti, and Madam Evangeline, the floor is open for you to discuss what I've just mentioned here.
It's fine, sir.
Yes, please. I'm just locating the next set of slides for the research methodology, which I will discuss now. Methodology of management research. I got those slides. Any comments? Anybody? I'm a little disappointed that we're not having as many interactions today as we had yesterday, but I guess that's probably because there's less number of us. I hope that the students who are not here will, you know, get back to looking at these slides later on and benefiting from this presentation.
It is okay, sir.
Okay, can I
Yeah.
then continue on with the
Yes.
last
Yes.
module, uh, which is looking at basically
Yes,
the
sir.
scientific method of research and how do we plan and set out a methodology for the research that we want to do. Okay? So I'll begin by saying that the scientific method is a number of steps that we undertake to solve any problem. Okay? And to make it a little light on all of us, because we are uh, normally would have many more interactions and many more examples. So to make it light, I'll read out a story to you. Okay. This is the scientific method story. One day, this is a Western story, so it says little Andy, but instead of Andy, I could say Anand. Little Anand was in a family gathering. They all sat together to have dinner. Then Anand told his mother, Mummy, I want to make lemon juice for everyone. And his mother told him, Anand, okay, dear, but do you know how to make lemonade? And Anand said, Yes, mom, I know how to make it. Anand ran to the kitchen and he was thinking, a lemon juice needs lemon, water, and sugar. He looked everywhere and he saw that he couldn't find the sugar. He asked his mother, Where's the sugar? I can't find the sugar. What should I do? Then he asked himself a question: What can I put in my lemon juice that will make it sweet? He started to search for information. What can be sweet like sugar? I have honey, I have jam, I have also got chocolate. Then he started to make a guess. I think the honey will be good for the lemon juice. He chooses the honey and decides to make a small experiment to try it. He puts the water, the lemon, and the honey together. It's time to taste it, he said. I hope it works. Hmm, it tastes so good. My experiment worked, he said. His family loved it too, and he was very happy. So he decided to write down what he found so he won't forget it. Now he has come to conclusion. Whenever I want to make a lemon juice and I can't find sugar, I'm going to use honey. Now let's try to answer some questions together to find out the scientific step methods. Because this little story I told you may seem very simple, but it answers a lot of the questions. What was the problem that Anand saw when he entered the kitchen to make a lemon juice? He saw that he cannot find the sugar. So the first step in the scientific method is to observe or see a problem, right? You may see it with your eyes as you walk down the street. You may see it as you go into a village and find that energy is a problem. You may see it as you go into a residential colony and see that food availability is a problem, or wherever. Or you may read up journals in your area and see that these are the gaps in the literature and this is where the problems are. When Anand couldn't find the sugar, what question did he ask himself? He asked himself, What can I put in my sugar to make it sweet? So the second step in the scientific method is ask a question. In fact, I always tell my students that when you come to class, don't come looking for answers. You should come looking for questions. Keep asking questions because that's the way to formulate the research problem. What other things did he gather as he searched for to put in the lemon juice? Anand gathered honey, jam, chocolate. So the third step in the scientific method is gather information. Get the things you can possibly find as solutions, and this is where the review of literature comes in. So once you have a research problem identified, please go through the review of literature, gather information on the particular problem. The next question Anand asked was, is honey the right choice? No, he thought. He wasn't sure whether honey is the right choice. So he just made a guess. The fourth step is exactly what we do in the scientific method, is to make a guess, the hypothesis. Hypothesis is a very sophisticated statistical term, and we have things like a null hypothesis, alternate hypothesis, so on. The hypothesis is just a statement or a expression of a gut feeling. Is a guess we are making that under these circumstances, this set of energy solutions or this set of products will work in this particular market. Going back to the story, what did Anand decide to do to be sure that honey is the right choice? Answer: he decided to do a small experiment to make sure the honey will taste good with his lemon juice. So, the fifth step in the scientific method is make an experiment. Very important to be able to make an experiment. The experiment doesn't necessarily have to be an experiment as in a chemistry lab or a physics lab. The experiment doesn't have to be a physical experiment with devices, products, reagents, chemicals, whatever. The experiment can also be a theoretical experiment, as many theoretical researchers would do. The experiment also can be an empirical experiment where we set out a hypothesis, we make a formulation of the problem, we identify a questionnaire, we go collect the data. All of this is part of the experiment. After Anand's experiment work, what did he decide to do so that he wouldn't forget what he found? Answer: he decided to write down or record what he found. So, the sixth step in the scientific method is record your results. Very important to document. In fact, when I was doing my PhD work at the University of California, I had kept a complete uh, a logbook of my research work, entire big notebook in which I would write everything that I was doing in the research, not just the results, but even the problem identification, the problem formulation, the mathematical modeling, the physical modeling, the design, the development, every bit. So every day in the morning when I'd come to the lab, I'd open this register, write down the date, and what I was doing that day. Every single thing was recorded. A very important part in the scientific method of research is to record your results. So at the end of this story, what conclusion did Anand make? Anand made the conclusion that he can use honey to make lemon juice when he couldn't find sugar. As simple as that. So the last step in the scientific method is draw or make a conclusion. Don't leave the data as it is. The data, as I explaining this, I think in another context, not here, I think in another seminar, we have something called data, we have something called information, we have something called knowledge, and then we have something called wisdom. This is an hierarchy going from data to wisdom. And to make data meaningful, you have to derive some knowledge from it. So, knowledge is nothing other than information is nothing other than data in a context, and knowledge is nothing other than information that is actionable. So, when you do any scientific experiment or any kind of research, please make sure that you draw or make a conclusion. Without the conclusion, there's no point really purpose of doing the research. Let me summarize the 7 steps of the scientific method or the research method. Step number 1: observe, see a problem. Very important. You have to keep our eyes and ears open all the time. And we do it best when we are very young. I remember when my children were, less than 5 years old, my daughters, every time I take them out somewhere, they'd keep asking questions. Papa, why does this happen? Why does this bus move? How does the bus move? I tell them there's an engine. He said, how does the engine make the bus move? So I say there is a transmission. How does the transmission take the engine power to the wheels? I explain the gears. Then they said, why do the wheels move when power is given? I explain the concept of traction. So on, so on. So you can see that when you observe a problem, all the questions start coming. And that's the next step in the research methodology. Ask a question. I'll give you an example again of a time when I was in the US, in Redmond, Washington State, and I'd been to visit the Microsoft office there. Fortunately for me, I could visit Mr. Bill Gates was there and had a good session with him. And he was appreciating how people of Indian origin have contributed so much to the growth of Microsoft. At the end of that, I asked him, sir, can India produce a Microsoft? And he said no. And I was shocked. I said, why not? I was also insulted. I said, how can he say that we cannot produce a Microsoft? And I asked him, why not? He said, Professor Iyer, you Indians are very good at answering the questions we ask you. but he said, you do not know how to ask the right questions. I thought that was very much a generalization, but I realized after a while that what Mr. Gates said had a lot of sense. We have to keep asking questions, and unless we ask the right questions, we'll never get to the answers, we'll never get to any meaningful research. Going back to the third step of the research method, gather or collect information. Information, information, information. The whole world is about information. Of course, people in the cultural area or in the Bollywood movies will say whole world is about entertainment, entertainment, entertainment. But that's not what we're talking about here. Once you gather the information, then we need to make a guess or the hypothesis. A guess is a layman's way of telling it. A hypothesis is a more sophisticated statistical way of saying that we are going to now formulate some statements, formulate some possibilities which can happen. So we can say a null hypothesis is that these set of independent parameters will not have any effect or will not influence the dependent parameter. The alternate hypothesis would be that no, these set of parameters will not only influence, but they may increase the dependent variable value or they may decrease the dependent variable value, whatever. Once you've made a guess or a hypothesis, the fifth step in the research methodology is to make an experiment. Do the experiment. As I said, experiment doesn't have to be a chemistry laboratory experiment. It could be any experiment, a physical one, a biological one, an experiment involving materials. Go to a lab and do the experiment, or an experiment without any physical materials. You could do an experiment empirically. You could do the experiment with modeling and simulation theoretically, but do the experiment. Once you do the experiment, please, please, please record your results. Lot of good work in our country gets missed out and people don't understand the value of record. Maintain the lab records. Everything you do in the lab has to be put on record. It will also be very useful later if you come up with an invention as a part of your research and you want to claim intellectual property. This lab record will be a proof of the fact that you carried out this experiment, you did the invention, you came up with a prototype, and you have a device that works now. Record your results. And finally, from the all the research work you do, as I mentioned earlier, please draw your conclusion. No research project is worth anything unless it comes to the conclusions. And as you would see when you write up your research thesis, the chapter on conclusion is the most important part of the thesis. Of course, equally important with the part I would call as the chapter 2 on objectives. So when you start out your research work, you say what are the objectives of the research? To analyze the effect of certain parameters on certain parameters, or to study the influence of the economy on the performance of a corporate, or whatever, whatever, whatever. And the results you get and the conclusions you draw should answer all the questions that you asked in your chapter 2 objectives. What are the research questions you are formulating as part of the step 2 of the research methodology? And what are the conclusions you are coming to draw at the end of your research study, which is step 7 of the research methodology? This is the scientific method. See a problem, ask a question, gather information, make a hypothesis, do an experiment, record the results, draw the conclusion. I hope you found this explanation of interest and use. And again, as usual, I will stop for a couple of minutes to take questions, answers, comments, suggestions, or any other feedback that you would like to give me. Any question? Anything?
So it was a good thing you shared with us. It will help us for in future research work and conduct market research also, sir. Design and develop new products to find out the market gaps, to find out the consumer preferences gap also.
Yeah, excellent. Thank you, Mr. Sanjay Bharti. You have summed up my presentation quite well. Professor Mishra, Professor Bholanath Datta, I know you are stalwarts. I am a very small person in front of you experts, but If you have any comments, please
No,
let me
sir.
have them.
No, sir. Your explanation and your the way you actually organized this particular, the research process is very much useful for our future research. Thank you.
Yeah. Professor Datta, no problem. Okay. If it is okay with you, I think that was the end of the formal presentation. I know we have a few minutes, but I also have to. I'm leaving early tomorrow for going back to Bangalore. Actually, I'm doing this from Trivandrum now, so I have to go back and pack up a few things. And I will share these presentations with you, Professor Datta, and you can put them out to the group members. And I am disappointed that we are just four of us here.